Hey everybody, in this video we are going to review right triangles, including Pythagorean Theorem and its converse, as well as special right triangles. So first, we've got two side lengths of a right triangle. We want the third. That's a good opportunity to use the Pythagorean Theorem. And that's a squared plus b squared, that's the two legs, a and b, equals c squared. C has to be the hypotenuse. So these are a and b, it doesn't matter which is which. X squared plus the square root of 7 squared equals the hypotenuse, c squared, square root of 19 squared. So that's x squared plus the square root of 7 squared. Anytime you have a square root squared, those just cancel each other out, plus 7. And the square root of 19 squared is 19. And we are going to subtract 7 and get x squared equals 19 minus 7 is 12. So x then is the square root of 12. Now we're going to try to simplify that. See if any square numbers go into 12. So 12... with this factor tree, let's see, we've got 4 times 3. 4 is 2 times 2. There's a pair of 2's. So a 2 is going to come out. So x equals 2 times the square root of 3. Here the legs are x and 12. X squared plus 12 squared equals the hypotenuse c, 13 squared. So that's x squared plus 12 squared is 144. 13 squared is 169, and we can subtract 144. 169 minus 144 is 25, and we will take the square root. The square root of 25 is 5. And last, the legs are 5 and 6. 5 squared plus 6 squared equals the hypotenuse x squared. That's 25 plus 36 equals x squared. 25 plus 36 is 61, so that is the square root of 61, or 61 equals x squared, and then we'll take the square root. And do any square numbers go into 61? So let's try a factor tree for 61. And really the only things that go into 61 are 1 and 61. So 61 is a prime number, so this radical cannot be simplified. So x is the square root of 61. Next, let's talk about special right triangles. Those are 45, 45, 90, and 30, 60, 90 triangles. In a 45, 45, 90, I always like to just write in 1, 1, square root of 2, and I let that kind of write a proportion for me. 6 is to 1 as x is to the square root of 2. And I can cross multiply and get x equals 6 times the square root of 2. In a 30, 60, 90, I write in 1, 2, square root of 3. So 1 is the shortest side, 2 is the longest, square root of 3 is the medium side. So for x, x is to 1, as 13 root 3 is to root 3. Now these root 3's cancel. One on top of the other cancels out, which really just leaves me with x equals 13. And then y is to 2, as 13 root 3 is to root 3. I could also have done 13 is to 1 since I know that x is 13, but this is going to turn into 13 over 1 because these cancel. And now I can cross multiply, and this is y times 1, and 2 times 13 is 26. And another 30, 60, 90, shortest is 1, longest 2, medium root 3, so I've got x is to 2, as 11 is to 1, and my cross products are x and 22. And I've got y is to the square root of 3 as 11 is to 1. And that's y times 1, and 11 times the square root of 3. Another 45, 45, 90, that's 1, 1, square root of 2. So x is to 1 as 9 root 2 is to root 2. And square root of 2's will cancel. So this is really x times 1 and 9 times 1. X equals 9. And last in this section, we've got a 30, 60, 90. Shortest 1, longest 2, medium root 3. So that's x is to 1 as 8 is to 2. 8 over 2 is 4. X over 1 is x. 8 divided by 2 is 4. X is 4. And then y is to the square root of 3 as 8 is to 2. So let's just, instead of doing 2 cross products, let's just multiply this one across. We get y equals 8 root 3 over 2, and 8 over 2 is 4. So y is 4 times the square root of 3. And then the last section here is the converse of the Pythagorean theorem. I want to know, for triangles with these different sets of side lengths, would they be acute, obtuse, or right? So I'm going to set these up according to the Pythagorean theorem. The two shorter ones would be the legs, 5 squared plus 12 squared, and then 13 squared. But I'm not going to put in equals because I don't know if they're equal yet. So in my calculator, I'll do 5 squared plus 12 squared, and that is 169. And 13 squared is also 169. And those are equal. Since those are equal, I know that would make a right triangle. Okay, then the square root of 8 squared plus 4 squared, and we'll compare that to 6 squared. Now I know that's 36. Square root of 8 squared, those cancel and I get 8. And 4 squared is 16. 8 plus 16 is 24. And 24 is less than 36. So if a squared plus b squared is less than c squared, that's going to make an obtuse triangle. 20 squared plus 21 squared compared to 28 squared. 20 squared plus 21 squared and 28 squared. So I get 841 and 784. 841 is greater than 784, and if a squared plus b squared is greater than c squared, that makes an obtuse triangle. I'm sorry, if a squared plus b squared is greater than c squared, that makes an acute triangle. And then 15 squared plus 36 squared compared to 39 squared. 15 squared plus 36 squared and 39 squared, and both are 1521, 1,521, and those are equal. And if a squared plus b squared equals c squared, then you have a right triangle. So if they're equal, it's right. If a squared plus b squared is greater than c squared, it's acute. If a squared plus b squared is less than c squared, it is obtuse.